chapter 5 covers loops and files. For now, we are going to cover loops, and then we are going to revisit files later on in the semester. So we are going to divide this chapter into two parts. The first part, the loops, we will cover now. The files we will cover later on when we need it. So if you remember, the motivation for loops that we had before was we asked ourselves what would happen if we want to cover, or if we want to calculate the area over a rectangle. And we said if we look at the flow chart for something like this, it would look something very similar to this one here. It's very simple, exactly this one. Basically, you start your code, you input length and width from the user, you calculate your area, and then you output the area. And then to motivate the idea, we said, now what if we would like to work with two rectangles, right? So if we want to cover two rectangles, in this case, we said, okay, the most intuitive way to do this is to basically try to calculate the area for the first rectangle, and then since this is going to work, just repeat the whole thing again. And what is that going to translate into in our code is basically a block of code that is going to be repeated a number of times, in our case here 2 times, with different variables, area 1 instead of area 2, and so on. So you have 2 areas, you have 2 lengths, you have 2 widths, and so on. And then we said, okay, now what about scaling up? So we always, whenever we write the code, we try to think about scaling. So 100, what are we going to do to it? Now, it doesn't make sense to go and repeat this block of code 100 times. There's no way you can do this. That's going to be insane, repeating that number of lines. The block of code, keep copying and pasting it, changing, and having 100 areas, 100 lengths, 100 width. That's not going to work. So the solution to this is that we need some new structure that we never had before, which is a structure that will allow us to go back and repeat the same process multiple times. So instead of going sequentially and trying to repeat the whole process 100 times, we would like a code. So we do it for one time, and then we would like some kind of a structure that will take us back and allows us to repeat that part again. So that is what we call a loop, something to loop over a piece of code. All right, so something that will look like this. So basically, here you go. You check a condition that will allow you to repeat something. You have to have a condition, right? So the process of repeating, it has to be tied to something. Why do you repeat? As long as I do not calculate 100 rectangles, keep repeating this code, right? As long as I have not filled the cup, keep dispensing the coffee, things like this. So basically here, what we are going to do is that we check a condition, and then we say if it's true, all right, execute the statements, and then go back and check again for the condition. Keep doing this until you get to the point where you are done. You covered the 100 rectangles. So are you still below 100 rectangles? No, then in that case it's false. Then you take the false path and go out of this loop. So that's the major concept. That's a very generic concept of loops. All right, so here we have 3 different looping structures in general in programming languages, most of the programming languages, and in our case here specifically with Java. So this video is going to cover the while loop. All right, so in the while loop, what is happening is that from its name, it says while a condition is still satisfied, keep repeating. So that's the major idea of the while loop. So while here a condition is satisfied, which has to evaluate to true or false. All right, so while this condition is satisfied, keep repeating whatever is inside these brackets. So that's how it would look like in case of the flow chart. So you have statements, and then you get to this point, and then say while the condition is satisfied, repeat the statements, go back, right, until the condition is not satisfied, then exit. All right. Now, because you check the condition before you execute the statements, we call this test. in this loop as the pretest loop. So while loop is a pretest loop. Now let's try and trace this code. So we initially have j is equal to 1. All right. So if I want to trace a code, I would go here and say initially j is 1. And then I say, okay, while j is less than or equal to 4, keep doing something. So is j less than or equal to 4? Yes. Currently it's equal to 1, so it's less than 4. So in this case, execute whatever statements you have here. So j is equal to j plus 1. So in this case, I increment j by 1. It becomes 2. And then I go back here, following this path, and then I ask, is j less than 4? Yes. Increment. Is 3 less than 4? Yes. Increment. Is 4 less than or equal to 4? Yes. Increment. Becomes 5. Now, after 5, you go back here. So now j became 5. Alright? So what you would do, come here and ask, is j less than or equal to 4? No. Then in this case, you exit point. So j, the last value for it, is going to be 5. Alright? So that is the trace of while loop, and then you go and print the output, which is going to be 5. Now, one thing that we need to think about here is that, okay, let's do this process of calculating the area of 100 rectangles. So initially I would initialize a counter to be 0, and then I go and check, am I less than 100? Is I less than 100? Yes. So in this case, I'm going to input length and width, calculate the area, output the area, and then go back and ask myself, is I less than 100? So here, this is going to repeat again, right? It's going to repeat. Now the question is that going to work properly? Alright, that's the question. Is that going to work properly? In other words, are you going to terminate eventually? Right? Are you going to get to that stop point here? The answer is no. Alright? The answer is no, because here I is equal to 0, and here the condition is I less than 100. And then if you notice here in all of the parts of the code that you are executing here, you are never going to change the value of I. So I is always equal to 0. Alright, and it's going to always be less than 100. So you will be repeating this infinitely. And this is what we call an infinite loop. Alright, so an infinite loop, it's a loop, it's a while loop that executes it executes indefinitely, alright, and that loop does not end, and that's why we call it an infinite loop. So here, an infinite loop could also, this is another infinite loop here, where we initialize x to be 20, right, and then our condition is that x is less than, greater than 0. So x is greater than 0, x is equal to 20, and here what we do is that we just print x is greater than 0, and here in this case, x will always be greater than 0 because x has never changed. So 20 is always going to be greater than 0. What we want to do to fix this is that to manipulate x eventually such that it violates that condition at a certain point. So if every time I execute the while loop I decrement x by 1, in that case eventually x will get to be 0, which is not greater than 0, and in that case the while loop will stop. Alright, so this is going to evaluate to false eventually. Alright, so that's what we want to do. Alright, the last thing here is that, okay, so now let's fix that. We here I is equal to 0, we are executing, and then the fix is that in your way back, to check the condition, increment I by 1. So that is your solution to make that loop here not valid. Alright. The other thing is that here we have seen this. If you have multiple statements to be executed, put it in curly braces. And as a good programming or practice, usually use curly braces for any structure that you're using. Have statements, even if it's a single statement, while anything that we're going to learn, usually try always to use the curly braces. Let's have a look at the code. So let's go to BlueJ and try to have a look add a couple of these codes. So here, this code is the tracing code. So here I have my structure, and then here what I'm saying is int j is equal to 1, while j is less than or equal to 4, j plus plus, and system with out of print line j. So here, if I run this one, it's going to print 5, right? Because j, once j gets to 5, 5 is not less than or equal to 4, I exit, and this is where I print j, right? So that is tracing the code. An infinite loop is a loop that its condition is not going to go false ever. So here, for example, int I is equal to 0, and then I say the condition is that I is less than 1, and 0 is less than 1. It will remain 0 less than 1 forever, as long as I'm not manipulating I. So here in this case, if I run it, it's going to be running indefinitely. That's an infinite loop. If you leave it long enough, it's going to crash your code, your computer actually. Sorry, BlueJ, the software. So in this case, you can go and just reset the JVM, and you're out of this loop. This is the code for the rectangle area. So here I'm just trying to show you the motivation of why we need loops. So here, this is single rectangle. You would do it this way after defining your scanner and prompting the user for the length, storing it in length, prompting the user for the width, storing it in width, and then calculating the area, printing the area. So that looks good. Now the question is, what if I want to do this 2 times for 2 different rectangles? And then in this case, you could go and do it this way, right? So here, length 1, width 1, area 1, length 2, width 2, area 2, and then print area 1, area 2. Perfect. As we said, 100 of these, this means 100 of this structure here, these 6 or 7 lines, which means 700 lines just to calculate the area of 100 rectangles. One way, as we said, to solve this is just to use the for loop. The for loop will allow you to go back and repeat the process as long as your condition is satisfied. So here in this case, I have my loop, auto indentation, and here I is equal to 0 while I is less than 100. And notice here the I++ is important to make sure that my loop is going to terminate eventually, right? This I is incrementing step by step, getting towards 100 until it gets to 100, which is not less than 100. In that case, you will get your false, and in that case, the while loop will stop. So here, as we said, just the 7 lines of code 1 time, enclose it in the while loop. It's going to repeat as many times as you want. So if I put some kind of a reasonable number here, let's say 3, and go here, run it. So enter the length, 10, 5, that's 50, and then 6, that's 56, 200, and that's 3 rectangles because our limit was 3. Alright, so 0, 1, 2. Alright, and one thing you could do to make this more customized is basically to use that I that is changing. So here I could, for rectangle, I'm here adding message, something like this. I plus 1. Right, and then plus. Alright, and do something like this here. Something like this, and the I plus 1 is because we start from 0, and I want to have rectangle 1. So here I could say 10, 5. And then it automatically goes to rectangle 2, 6, 6, 200, 500. So this way I utilize this I, which I know is going to change anyway. It's my count. And I try to utilize it to make this message a little bit more custom. Right? So that is how to use the basic for loop. The last thing we will do before we move, before we are done with while loops, with the while loops, is to discuss how can we use the while loop for just more than repeating a process like this, like counting a process like this. One significant use of the while loop is to do what we call input validation. Basically, you're trying to validate the input of the user, and if it's wrong, you go back and reprompt the user. All right, so far, if in our case, let's say I ask you for a number between 0 and 100, you enter the number, all right, and it could be outside the range. We didn't have any process of going back and asking you know what, you entered the wrong number, re-enter the number, right? So that's input validation. So input validation is to try and ask the user for any number of times, as long as the user is entering an invalid input, until the user enters a valid. So here's a very simple example. Enter a number in the range of 1 through 100. So I'm asking you to enter this. Then using my keyboard, the scanner, I'm going to use next int to get the number and store it in the variable number here. All right, so that is my variable number. This is where I'm storing this. So, all right, there we go. All right, so what I'm going to do is to say I want to validate this input, which means if the input is not valid, if the input is wrong, or if it's true that the input is wrong, I would like to go back and reprompt you for the input. All right. Now, here's how this works. We know that the while loop works if it's while true. So that true, what do we want to check? It's true that the input is wrong. So if it's true that the input is wrong, process this. So that's basically what we are saying. We are saying that if it's true that the number is less than 100 or greater than 100, less than 1 or greater than 100, then it's true that the number is wrong. And in that case, I would like to go and prompt the user again. So here, basically, I'm still trying to get used to this tool. So here, we are going to reprompt you again. So here I'm printing a message that tells you that the number is invalid. So please enter the number from between 1 and 100. And then I retake the number again. Now, once I take the number again, notice here that the previous true statement allowed me to do this process, which gives me a new number now, the one that you just entered. Then I go back to the header of the while loop, and I check the condition again with that new number. You enter it wrong again, I go back and prompt you again, and then I go back with the new number and check again. And I keep doing this until your number is correct. Now, if your number is correct, it will neither be less than 1 or greater than 100. Right? So it will be false or false, which gives you false. All right? So that's how you validate an input using the while loop. So let's go here and have a look at this input validation. I think we are at 20 minutes. Once we are done with this, we can conclude this video. So here is what we are going to do. Here I'm going to divide my scanner, keyboard, and then I'm going to prompt you, input the number, and then I'm checking if it's less than 1 or greater than 100, and then I'm going to keep prompting you as long as you enter the wrong number. Once I clear this while loop, this means I have detected a valid input, and in that case I'm going to print you that you entered the valid input. All right, so if I compile this one, 500. So I take 500, store it in number, go, is 500 greater than 100 or less than 1? Yes, of course, it's greater than 100. Go and reprompt by saying the numbers are invalid, go back and reprompt it. Then I prompt the user again, and then I enter something like -50, and again it's less than 1. And then I enter something like 40. And in that case, you enter the valid input, and that means I clear the while loop, and now I'm printing that message. All right, this is exactly equivalent to saying that the number, while the number is not greater than or equal to 0, and number is less than or equal to 100. All right, that would be exactly the same. Right? There we go. All right, and if you think about it, it's actually exactly the same. It's the same thing, right? When you think about it here, let's see. So let me try and write this here. So saying not number, I would say n is greater than or equal to 1, and n is less than or equal to 100. So if you expand this one, it's not n greater than or equal to 1, or not n greater than or equal to, so it's less than. All right, so not greater than or equal means it's less than, or not less than or equal means it's greater than. And this is basically what we just had here. So that's how you move from one condition to the other. Either way, you'll get the same result.